All right, let's do some examples with hyperbolas. All right, first example, identify the vertices and foci of the hyperbola with this equation. Okay, so let's see, we have y squared is the positive term. So that tells us that our transverse axis is going to be the y-axis. This is going to open up and down, right? Okay, so just generally, what's this going to look like? I have to be really careful here. It's going to open up and down, centered at the origin, right? Because it's just x squared and y squared. So here's our center. Our A term is 7, right? So this is going to be at 0, 7. And this will be at 0, -7. All right, how about the foci? What are the foci? Well, remember for a hyperbola, c squared equals a squared plus b squared. Yeah? So we know what a squared is and we know what b squared is, right? Here's a squared, here's b squared. So c squared equals 49 plus 32, which is 81. Oh, that's convenient. So c is 9. So our focus, remember, is inside the hyperbola curves. So this is going to be at 0, 9, and this will be at 0, -9. Right? It's c units from the center of the hyperbola. Okay? All right, let's do another one. Example 2. What is the standard form equation of the hyperbola that has these vertices and these foci? All right, well, let's think about this. Again, we can just kind of roughly graph this out. Plus 6, 0, and minus 6, 0, those are the vertices. And the foci are at 2 square root of 10. So it's going to be like a little bit more than 6. So somewhere over here and here. So a hyperbola is going to look something like that, right? So we know, let's see, what do we know? We know our transverse axis is the x-axis, right? This opens along the x-axis. So we know our equation is going to have and the center, it's at the origin, right? Because the vertices are in either 6 units either way from the origin. So we know the center is at the origin. So let's see, we know it's going to have the form x squared over a squared minus y squared over b squared equals 1. Right? Because the x-axis is the transverse axis. And we know a few things. We know a already, right? We know that a equals 6. And we know that c equals 2 square root of 10. And we know that c squared equals a squared plus b squared. So we need to solve for b squared. Okay, so c squared, let's see, is going to be 2 times square root of 10 squared, which is going to be what? 40, right? 2 squared is 4, square root of 10 squared is 10, 4 times 10. So this is going to be 40 equals 36 plus b squared. All right, cool. 4 equals b squared, b equals 2. All right, so now we just need to put this in our equation. X squared over 36 minus y squared over 4 equals 1. It's not so bad, right? Right now, the graphs are just really rough, right? We're just doing the graphs to kind of get our thoughts centered. We're not doing careful graphs yet. We'll do careful graphs in a minute. All right, let's find another example. Example 3. There's example 3. Okay. What is the standard form equation of the hyperbola that has vertices at 0, -2, 6, -2, and foci at -2 and 8, -2? This seems like one I'm actually going to graph kind of carefully. because I'm going to have to figure out where the center is and things like that. And again, you can figure it out algebraically. Just keep things straight in your head. I prefer to do it graphically. So, all right, so the vertices are at 0, -2, and at 6, -2. Those are the vertices. And the foci are at -2, -2. Or foci, what did I say? And 8, -2. All right, there's the foci. All right, cool. So it's just going to look like this, right? Except actually go through the points. All right, so where's our center? It's going to be halfway between our vertices. So let's see, the center is at 3, -2. Our A value is the distance from the center to the vertex, to one of the vertices. So that's 3, right? And our C value is the distance from the center to the foci, or focus point. 1, 2, 3, 4, 5. So C is 5. So if that's the case, we can figure out what B is, right? So C squared equals A squared plus B squared. So 25 equals 9 plus B squared. We can subtract 16 equals B squared. B equals 4. All right, I think we have enough to put it together into an equation. Which is our transverse axis? This opens along the x-axis, so our x term is going to come first. So it's going to be x minus 3, right, the center, squared over A squared, so over 9, minus y minus -2, so y plus 2 squared over B squared, so 16 equals 1, right? And C doesn't show up anywhere. One thing I want you to notice, in this case, our B is bigger than our A, and that's fine. For ellipses, that's not fine, but for hyperbola, that is fine, right? Just whatever term is the transverse axis needs to be the positive term. All right, so that's cool. All right, let's do another example. Woo, drink our water bottle. All right, example 4. All right, graph. Let's graph this hyperbola given by this equation. All right, so it looks like it's centered at the origin. A is 8 and B is 6. So let's be kind of careful about this, right? So here's our center. The transverse axis is our y-axis, right? That's the positive term. So it's going to open up and down. So we'll go 8 units in either direction in the y-axis direction. 1, 2, 3, 4, 5, 6, 7, 8. Oh, probably didn't make this quite big enough. That's too bad. And this one, we go 1, 2, 3, 4, 5, 6, 7, 8 this way. Okay, so there's our vertices. So far, we've kind of been ignoring our B value, right? Our B value goes the other way. Our co-vertices are going to be 6 units. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 here. All right, and now we're going to make one of these dotted boxes. Okay, we're going to make a box that's as wide and as tall as our vertices and co-vertices are. Okay? And now I'm going to make a line that goes through the center and through the corners of this box. Those are my asymptotes. Okay? The only thing I'm missing here are my foci, right? And how could I figure those out? C squared is going to be 64 plus 36, which is 100. So my C is 10, right? Square root of 100. So here's my one focus point, and my other one, I cleverly didn't make this quite big enough. So I'm going to pretend, that looks like it fits, right? I'm going to extend my graph paper. There we go. There's my 2 focus points. And now I remember, okay, I know that the transverse the axis is y. It's going to open up and down. So I go from this vertex and I connect it all the way almost to these asymptotes. And now I go to this vertex and I go all the way almost to those lines that are my asymptotes. And there we go. That's my hyperbola. If I needed to find the slope of this line, what's it going to be? Well, the change in y is a, and this one is b, right? So the slope of this line, if I wanted to find it, the equation of this line would be y equals 8 over 6 times x, right, with no y-intercept. And this one would be minus y equals minus 8/6 x, or 4/3, right, if we wanted to reduce it. Hey, it's not so bad, right? Those diagrams that in the last section just looked so complicated, but this isn't so bad, right? We find our vertices, A, our co-vertices, B, draw this little box, connect the corners, and then just draw from the vertices down to the asymptotes. It's really not that bad. It's much better than it seems like at first when you first see the diagrams, I think. All right, let's do another example. Let's do example 5. Uh-oh. Graph the hyperbola given by this equation. Identify and label the center vertices, co-vertices, foci, and asymptotes. Whew, all of it. Again, this is as bad as it's going to get. We can do it, so let's do it. We're going to have to complete the square, right, to be able to find anything out about this at all. All right, how do we do it? Let's group the x terms, group the y terms, bring the constant to the other side. And now this looks just like what we've already done, right? We factor out the 9. Factor out a minus 4. Okay, now we got to complete these squares. Negative 4 divided by 2 is negative 2. Squared is 4. So I add 4. But on this side, what do I add? 9 times 4. Right? I add a 36. All right, 10 times 2 is 5. Squared is 25. So I add a 25. But over here, I add a minus 100. Okay? All right, now let's write this as a perfect square. And what is this? 288 plus 36. No idea. 324, I think. I hope. 288 plus 36. Yeah, I think 324. Let's cheat. 324, yes. That's what I say too. All right. Cool. That looks much better. What do we need to do next? We need this to be 1. So we divide by 324. I'm getting out my calculator. Where's my calculator? Okay. So 324 divided by 9 is 36. And 324 divided by 4 is 81. Those look like encouraging perfect squares. All right, now we're in business. Now we know the center is at 2, negative 5. We know it's hyperbola because this minus sign here. We know A is 6. We know B is 9. We could find C. C squared is 117, the square root of that. C is the square root of 117. All right, let's graph it. Move this out of the way. There's the equation that we need. Okay, and the transverse axis is x. This is the positive one, so it's going to go 6 units either direction that way. All right, and the center is at 2, -5. So let's make sure to make this big enough. So at 2, -5, there's our center. All right, to find our vertices, we're going to go 6 units along the x-axis. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. To find our co-vertices, we're going to go 9 units along the y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, what do I do next? I make my little box, right? I just make a box connecting these vertices and co-vertices. You really have to make the box, right? If you don't make the box, like, it's just you have to make the box. All right, and now we connect the corners of the box, go through the center. Nice. And we could find our focus is going to be square root of 117. So just like a little bit more than 10. So like there and there. Oh, wait. Wrong way. Sorry, those aren't our focus points. Our focus points are along the transverse axis, which is x. Right, so we go 10 units, a little bit more than 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So like about right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So like about right there. All right, so now we go from our vertex. So you can see one easy place that's easy to make a mistake is to kind of forget which axis is your transverse axis, like I just did. So this is opening along the x-axis. So here's our vertex, and we go up kind of along the asymptotes like that. Well, that should probably be closer. Kind of like that. And our foci are inside the shape. Cool? All right, let's do, so they don't get any harder than this. This was like as bad as it gets. We had to complete the square, find our equation, and then from our equation, we made a graph. Are you impressed that a little while ago you had no idea about any of this, and now here you are drawing hyperbolas? Amazing. All right, one application. I did not know this, but apparently an actual real-life application of these are cooling towers. Okay, they make the sides of the cooling towers hyperbolas. Okay, these are 2 sides of a hyperbola. Cool. So let's do one application problem like that. A design layout of a cooling tower is shown in figure 11. The tower stands 179.6 meters tall. The diameter of the top is 72 meters. At their closest, the sides of the towers are 60 meters apart. Find the equation of the hyperbola that models the sides of the cooling tower. Assume that the center of the hyperbola is indicated by the intersection of dashed perpendicular lines in the figure, right here, is the origin of the coordinate plane. Round final values to 4 decimal places. Okay. So let's do a quick graph here. Let's assume that this is the center. And here's, let's say these are the vertices. And it goes like this. They tell us that this distance is 30 meters, right? Because the whole distance across, whoa, you can't see what I'm drawing, sorry. The whole distance across is 60, right? This whole thing is 60. So this distance here is 30. And what else do they tell us? The whole thing is 179.6 meters, and this is 79.6 meters. What do we really need to know here? They want us to find the equation. So first of all, we can say the x-axis is our transverse axis, right? So it's going to be of the form, we're saying we're going to find an equation centered at the origin. So it's going to be the form x squared over a squared minus y squared over b squared equals 1. And we know a, right? A is 30. So 30 squared minus y squared over b squared equals 1. All right. What do they do here? Oh, we're going to have to plug in a point. It's a drag. Can you tell that I kind of wing these? I'm sorry. I do sometimes. Sometimes I'm very careful, but this one I'm just winging. So let's just look at what they do. So here's our equation. They say, okay, well, we can solve for b squared in terms of this stuff. And we know a point, a y point, they say is 79.6. Why would it be 79.6? 79.6 is the distance right there. Oh, so here's a point. Sorry, I really should have read through this problem before. So here's a point that they give us on the parabola, right? What is that point? It is, the y is 79 and the x is minus 36. We could do it either way, right? Let's do it over here. This is going to be at 36, 79.6, right? This point right here, or this point right here could be at negative 36, 79.6. And we can plug that point in for our x and y values and solve for b. Right? So we could say x squared, so 36 squared over 30 squared, minus 79.6 squared over b squared equals 1. All right, we can use that to solve for b. Right? So that's why they gave us this extra measurement here, is so that basically we could find a point on this hyperbola. Obviously, I don't think this is like super important since I didn't even look at this problem. Okay, all the stuff up until now, you definitely need how to do. I don't even think you have an application problem in your homework. I'm not totally sure. But if you did, this is how we do it, right? We would find the general form of our equation, figure out which a or b values we already know, and just like we always do, if we need to solve for another constant, we need another point on the equation, on the graph. So we look back here and we noticed, aha, they gave us this point, right? This distance is 36, this distance is 79.6, and we can plug those values in for x and y, and then we solve for our b squared. I don't think I'm going to bother doing that. Since they did it for us, let's just look what they get. Turns out b squared is 14,400.3636. And then you can put that back in. You take the square root of that. Well, you don't have to even. Here's our equation, right? There's our b squared. Ta-da! So I'm being a little bit dismissive of this problem. However, conic sections are surprisingly useful. They actually are used in things like space exploration and in building design. Like we talked about for ellipses or this for hyperbolas, it's legit. They actually use them for things like this. So this is one of those things that you might actually use someday. And that's hyperbolas. Good luck on the problems. Let me know what questions you have.